morning. I am Dr. Niti Maheshwari, Assistant Professor, Applied Science and Humanities Department, Ajay Kumar Garg Engineering College, Ghaziabad. In my last lecture, I had started water and its treatment. What is hard water? I had explained, and what are the different units, and why do we convert the hardness in terms of calcium carbonate equivalents. Now, coming to the effects of hard water. What are the effects of hard water? Now, first, this hard water, it is harmful for drinking because of the presence of excess amount of calcium and magnesium ions. Because these calcium and magnesium ions, they tend to accumulate in the body and cause different diseases. Then, hard water used in boilers, it results in the formation of scale and sludges. I will discuss later what exactly I mean by scale and sludges, and they result in corrosion and they cause caustic embrittlement of the boilers. Then, next problem encountered with hardness is that the hard water, it does not give lather with soap. Therefore, it sticks to the clothes and the body. And the hard water, it causes blockage in the holes because these ions, they accumulate, therefore it causes blockage. And the hard water, it is also not useful for laboratory analysis because the hardness producing ions, they interfere in the different reactions. Now, coming to the boiler troubles. Boiler troubles, we not only use water in the for domestic purposes, but also in different industries, and we also use boilers for the production of electricity. So, huge boilers are there where we boil water and it is used for the industrial purposes. So, the different problems encountered in the boilers because of the presence of hardness in water. The first problem encountered is the priming. What exactly priming means? It is the formation of the water droplets with steam, and these water droplets, they are persistent in nature. That means they do not break down easily. So, priming is nothing but the carrying out of water droplets with steam, and because of rapid and high velocities of steam, the water droplets, they move out with the steam from the boiler, and this result in the formation of wet steam. And this wet steam generation, it is caused by the presence of large amount of dissolved salts. It is also caused by the high stream velocities, then by sudden boiling, then by improper designing of boilers, and it is also caused by sudden increase in steam production rate and high levels of water in the boilers. So, this priming is one thing which interferes with the working of the boilers. Next is the foaming. So, foaming is nothing but the bubbles which are formed at the surface of water. When water boils, it forms persistent bubbles, and these bubbles, they do not break down easily. So, the formation of stable bubbles at the surface of water in the boiler is called foaming, and more is the foaming, more is the priming, and it results with the formation of wet steam that harms the boiler cylinder and turbine blades. And foaming is due to the presence of oil droplets, grease, and some suspended solids. It is generally, foaming is generally formed when the water is alkaline in nature. That means the pH of water is greater than 7. Now, the next problem encountered is the formation of scale and sludge. The water in the boiler, it is continuously heated, and it causes the increase in the concentration of dissolved and suspended solid. We take in the hard water, the water boils and evaporate, but the solid, they keep depositing at the lower surface of the boiler. These are precipitated and they slowly precipitate on the inner walls of the boilers. They get accumulated on the inner walls of the boilers, and this precipitation, it takes place in two different ways. The precipitate that is formed inside the boiler, it can take place in the two different ways. First way is if the precipitate that are formed, if they are loose and slimy in nature, then it is known as sludge. And if the precipitates that are formed, they are hard and they stick adhering to the walls of the boiler, then they are known as scale. So the sludge that is being formed, it is the muddy solid at the bottom of the boiler, or it is loose, slimy and soft deposits in the boiler, and they are called as sludge. And these sludges which are being formed, or the loose precipitate which is being formed, it is caused by the presence of magnesium carbonate, magnesium chloride, calcium chloride, because they have more solubility in hot water. And the disadvantages of sludges, now these sludges, they are bad conductors of heat, and the results in the wastage of heat and fuel. Now the sludges, they get entrapped in the scale and get deposited at scale because more loss of efficiency of the boiler. The excessive sludge formation, it leads to settling down of sludge in slow circulation, and the areas such as pipeline connections, it leads to the choking or the blockage of the pipes. So these sludges, with time they get settled down and they cause the blockage of the pipes. And how we can prevent the sludge formation? By using soft water which is free from dissolved salts, like I have already discussed, like magnesium carbonate, magnesium chloride, calcium chloride and magnesium sulfate. And these sludge formation, it can be prevented by the blow down operation also. Next precipitate is the scale. Now scales are the hard precipitate, and they sticks or the sticky precipitate which get deposited on the inner walls of the boiler, and these scales, they are very difficult to remove. And the reason of the scale formation is the decomposition of calcium bicarbonate at high temperature and pressure in the boiler. What happens? This is calcium bicarbonate. Here calcium bicarbonate at high temperature and pressure, it gets dissociated to form calcium carbonate and carbon dioxide and water. And this calcium carbonate which is being formed in water, it is the insoluble salt that settles as precipitate in the boiler. I have already discussed that we take or we convert all the hardness in terms of calcium carbonate equivalents, because generally this calcium carbonate is not present in water. So this precipitates out of water and it gets deposited at the inner walls of the boiler. The second main reason is the presence of calcium sulfate. Now this calcium sulfate which is present in water is highly soluble in cold water and it is less soluble in hot water. So when we heat water, it precipitates out as the hard scale, and whenever the temperature of the boiler is increases. So while heating, this dissolution of calcium sulfate reduces and it gets precipitated at the inner walls of the boiler. Second or the third reason is the hydrolysis of magnesium chloride. Now the dissolved magnesium chloride which is present in water, it is precipitated as magnesium hydroxide at high temperature, and then it gets deposited as scale. So here magnesium chloride in the presence of water, it forms precipitate of magnesium hydroxide and results in the formation of HCl. So, this magnesium hydroxide, it gets deposited in the boiler as scale. The fourth main reason is the presence of silica. Now, this silica which is present in the water, it deposits as calcium or magnesium silicates, and these deposits again they are very hard. Now, what are the disadvantages of the scale formation? As scale is very hard and it sticks to the wall of the boiler, it is very bad conductor of heat. So, again there is a lot of loss of heat and fuel, and due to the scale formation we have to heat the boiler to high temperatures, which causes the weakening of the boiler material. And because of these scale, again choking of boilers is also observed, and because of the uneven heating, because deposition of precipitate is not going to be even, therefore because of the uneven heating there may be even development of cracks in the boiler, and whenever the water passes through this crack, it comes to contact with boiler plate, it generates sudden steam and high pressure results, which can cause the explosion of the boiler. Now, removal of scales. If the scale is soft, it can be removed by scraper. You can scrap and then you can remove the precipitate by giving thermal shocks also, that is done by heating to higher temperature and sudden cooling. Even then the scales can come out from the boiler. The calcium carbonate scale, it is removed by washing with 5 to 10% HCl solution, and calcium sulphate scale is removed by washing with EDTA solution. By blow down operation also we can remove the scale. Now, here in this diagram I am showing the formation of sludge and scale. Here you can see on heating loose slimy precipitate is being formed, which is known as sludge, and this is the scale formation, which is the hard precipitate which is adhering to the walls of the boiler. The next problem encountered is the caustic embrittlement. If water is alkaline, it contains sodium salts, it contains sodium carbonate suppose, then the presence of sodium carbonate in water, this sodium carbonate, it gets hydrolyzed in high pressure boilers, and on hydrolysis it produces NaOH plus CO2, and this NaOH which is being formed after some period of time, it gets concentrated and it causes the intergranular cracks in the boiler walls, especially at the stress points. As a result, it causes the embrittlement of the boiler. Embrittlement is nothing but weakening of the walls of the boiler, and ultimately the boiler walls get cracked down. So, the formation of cracks in boilers due to the NaOH presence is called the caustic embrittlement. Though we are not having directly using NaOH, but this NaOH is being formed by the presence of sodium carbonate in water. Now, so there are a lot of problems which are encountered by the hard water. So, how can we remove these hardness from water? So, coming to removal of hardness. To remove hardness from water, 3 methods they are used on a large scale. There are 3 methods which are being used. The methods that are being used is first permuted process or the zeolite process. Then second is the ion exchange process, and the third is the lime soda process or the soda lime process method. These are the 3 processes which are used at a large scale. And the another method which is used, this is for internal softening of water, that is Calgon, and reverse osmosis is also a method for the removal of hardness from water. Coming first to the zeolite process. If we see the chemical structure of zeolite, generally it is sodium zeolite which we are using, and it is represented as Na2O3, SiO2, X SiO2, Y water, where X is 2 to 10 and Y it is variable from 2 to 6. So, zeolite is nothing but hydrated sodium aluminosilicate. It is a mineral which is capable of exchanging reversibly its sodium ions for hardness producing ions in water. Now, in zeolites, it is general representation of zeolite is Na2Ze. Now, these sodium ions which are present in the zeolite, they are loosely bonded to the zeolite. So, the process involves the exchanging of these sodium ions for the hardness producing ions in water. So, these zeolites, they are of two types, natural zeolites and the synthetic zeolites. The natural zeolites, they are non-porous and their exchange capacity is also low. For example, natrolite. Natrolite is Na2Al3O3, 4 SiO2 and 2 water. And the synthetic zeolites which are prepared in labs by the combination of Na2O3, then Al2O3 and silica, they possess the gel-like structure and they have higher exchange capacity than the natural zeolites. So, here I am showing the process of zeolite, how the zeolites, they are able to exchange the hardness causing ions for the sodium ions. Now, in this diagram, this is the zeolite bed which contains Na2Ze. Then we have the gravel, this is the hard water inlet. Here there is NaCl solution which is the brine solution, it is used for the regeneration of the zeolite. So, here what we do, we pass the hard water. As I have already discussed, hard water is nothing but that water which contains calcium, magnesium and salts of heavy metals like aluminium, iron and manganese. So, water containing these ions is the hard water. I pass this hard water through the zeolite bed. When this water passes through the zeolite bed, then the zeolite bed contains sodium ions. So, here while the water is passing through the zeolite bed, these reactions are going to take place. First reaction, you can see that the sodium ions which are present in zeolite, they react with the calcium sulfate. Exchange process takes place and the calcium ions, they get adhered to the zeolite and they form the precipitate, and the moving water, the water which is going to pass through the zeolite bed, it will now contain sodium sulfate. Similarly, the magnesium sulfate which is present in the hard water, when it passes through zeolite, then the magnesium get attached to the zeolite and the sodium ions which are present in the originally present in the zeolite, they move out of the zeolite and they move into the water. And now the water again, it contains sodium sulfate. So, these are the different exchange reactions which are going to take place when the hard water will pass through the zeolite. And now after passing through the gravel, this water will contain the soft water. Soft water, that means this water will not contain calcium salts or the magnesium salts or aluminium salts. So, these salts will not be present in the water, and we can collect the soft water which can be used for the boilers. Now, after a certain cycles, this zeolite bed will get choked, or it will stop acting as a pure zeolite, or the exchange capability of the zeolite will decrease considerably, because the sodium ions which are originally present in the zeolite, now their place has been occupied by the calcium and the magnesium ions. So, the calcium and magnesium, now this zeolite will contain calcium Ze and magnesium Ze. So, this zeolite will not be able to exchange of the hardness causing ions and then convert the hard water into soft water. That means this zeolite bed is exhausted now, and it has to be recharged or regenerated, so that we can again use it for the exchange reactions. So, for that purpose, what I do, I stop passing hard water now. I stop passing hard water, and then I pass brine solution. Brine solution is nothing but concentrated NaCl solution. So, I pass my brine solution, and when I pass my brine solution through this zeolite bed, again what is going to happen, since this brine contains NaCl, the reaction will take place in the reversible manner, and the places which calcium and magnesium had taken, they are again going to be occupied now by the sodium ions. So, I will pass NaCl and regenerate my zeolite bed, so that again it can function as the original zeolite and the exchange process can take place. So, after regeneration, I will pass this water or the solution containing calcium chloride or magnesium magnesium sulfate, and I will send it to the sink. So, after cleaning my zeolite bed, now again I will start passing hard water till again it gets exhausted, and I will continue this process till the regeneration capacity of zeolite get reduced. So, this is how I use the zeolite softener. So, here I have already discussed that after some time the zeolite is completely converted to the calcium and magnesium zeolites, and it ceases to soften water. That means it gets exhausted. At this stage, the supply of hard water has to be stopped, and the exhausted zeolite is reclaimed back by treating with the concentrated NaCl solution. So, here on treating the calcium or the magnesium zeolite with concentrated NaCl, I convert them back into sodium zeolites, and calcium chloride or magnesium chloride is being formed. Now, these washings, they are led to the drain, and the regenerated zeolite bed which is now obtained, it can be used again for the softening process. Coming to the limitation. Now, this zeolite, it has certain limitation, that in zeolite process the sodium ion are replaced by the calcium and magnesium ions. That means the soft water contains excessive amount of the sodium ions. If the hard water contains acid, then it destroys the zeolite bed. That means the zeolite bed is sensitive to the acid. And if the water is turbid or it has suspended impurities, then it will again block the pores of the zeolite. If bicarbonate and carbonate ions are present in water, they are converted as sodium salts, resulting in the alkalinity of water. The colored ions, which are manganese and iron, they cannot be removed by water, because they react with the zeolite bed and they form strong bonding with the zeolite. So, if your water contains manganese and iron, then it has to be removed first, only then the water can be passed through the zeolite bed. Then if the supply of water is turbid, then it will clog the pores of the zeolite bed. And the mineral acid, it destroys the zeolite bed. Coming to the advantages, the hardness of the water is removed and it is about 10 ppm, and therefore the soft water is obtained by this process. It is easy to operate, it occupies less space, scale and sludge is not formed, the process can be made automatic and it can be continuous in nature. The process is cheap since regeneration of the permatite is used again. But I want to discuss one disadvantage, that the anions, they cannot be removed by this process, only it is the process for the exchanging of the cations. Thank you.